So now with our struct done, we can actually go and make a data table inside our project. Right click and go down to miscellaneous, select data table, and make sure that the row structure is gameplay struct. Sometimes I don't know why they have a duplicate, but just click on one of them, and I'm just going to call this one gameplay data. So if we open that up, you can see here we just don't have anything in it currently, but if I add a new row, now we have something like this. So like since it's the first row, we can say that it's the first sequence, which first sequence would be 0. You know, we would say, oh, this lasts 10 seconds, the scene is game 1 or game 0. You know, it has 5 enemies, etc, etc, etc. A much easier way to work with this is if we were to export this as a CSV file, edit it within something like Google Sheets or Excel. Before we do that though, I'm just going to quickly add 1 to each of these arrays. So then once we actually export it, we'll have the right kind of structure here to work with. It means that once we export it and we go to Google Sheets, you see here we already have this stuff like X, Y, and Z all in its brackets and stuff like that already set up for us. So we know which format that we need to be working in. So to export this data table sheet and get it into something like Google Sheets, just right click on it and go up to the top and export as CSV, and save it somewhere where you will remember it on your computer. And if you want to do this with Google Sheets, then here we would upload it to our drive. If you want to use Excel, you would just open up the file directly from your computer hard drive. But here I'm just going to upload that CSV file. And once it is uploaded, it's going to be in a Word doc format, but we can just right click on here and go open with Google Sheets. So now here we have it. We have a data table sheet inside a much easier to use environment. Now I'm just going to create maybe 10 rows worth of data just for a very short and quick gameplay sequence. You can follow along with the data that I'm inputting here, or you can play around with it the way that you would like to. Now all of these columns here, all of the data in here should be inside brackets to tell Unreal Engine that these are actually array values. I'm not actually sure why some of these only exported in just single digits like this. It's probably because when I exported it, I only had like a single value in the array. So maybe if you export it while it's putting in like a couple more, then it'll have that bracketed format. But inside actor, we could say, hey, like 0 would be one kind of enemy ship, 1 would be another kind of enemy ship, etc, etc. You'd have all your different enemy ship types set to a different number value. And on a per sequence basis here, we've got like three enemies spawn here, 5 enemies spawn here, etc, etc. And they come like 6 seconds after the last, 6 seconds after the last, etc, etc. This is basically how quickly we can set each like mini wave to be. So if we wanted these 3 enemies here spawning in our first sequence to all be different enemies, we would have a bracket, would go 0, 1, 2, close bracket, like that. So then each of the 3 enemies would be a different type of enemy ship. But a quick cheat that you can do to have it, like if you want every one of these to be the same kind of enemy ship, let's say, like we want it to be enemy ship type 0, let's say. So you could just type a 0 in and put a little star symbol in there. It's just the capitalized 8 on your keyboard, and then sort of like that we can use that in code to say, hey, if we have an array that only has one value in it, in this case the single value is a 0, then we can apply that value to all enemies that we want to have spawned in. So for now, if we're just working with a single enemy ship type, we can just drag that down and have all of these be the same kind of enemy. If, let's say, you wanted this last sequence here, which has 5 enemies in it, if you wanted them all to be in like a let's say they're all in like a V-shaped pattern, and we want the enemy that's at the front of that V-shaped pattern to be a different, like, special kind. The way that you would lay that out then is you'd have 1 for that special ship that we mentioned, and then 0, 0, 0, 0. So then once we go to our locations, our first vector variable that we can set can say, hey, this ship that's a different kind, our number 1, set that in a spawn location that's at the front of our V pattern, and then all these other zeros here are just the standard ship types that follow it. So for movements, for now we can just set this to be one type. So 0, star symbol, close bracket. Let's just drag that down and fill all those rows. For health, same kind of thing, except we can set their health to be 20 on all of them. Except on our last one down here, if we wanted that one ship type there to be a little bit stronger, we could say open bracket 40 and then comma 20, 20, 20, 20. So then that way we have a different kind of ship here at 40, and then all these other ship kinds here, they're all at 20 health. Here we have a move speed multiplier, which will work with our movements, and if we want to have it so that there are no movements at all, we can basically say, like, hey, we want our float variable here just to be 0, because when you multiply by 0, it just means we get 0. So it doesn't matter what our movement is set to, this move speed multiplier. If it's a 0, then they won't be following any kind of movement pattern, they'll just be moving down the screen straight to the player. So then we can set all these just to be 0, but for an example later we could say, hey, we want these 5 enemies here, let's have them be set to 1.0, and then they'll have a sort of standard movement speed following this movement pattern. For X and Y multi, we can just condense these down a little bit so they don't use so many numbers, and let's just drag that all the way down. And then for the one where we've set, hey, actually we want some move speed, we could say, hey, like on the X-axis you're moving 300 units, and on the Y-axis you're moving 100 units. Velocity, the movement speed that we have the ships coming down at us, we can just set that to 1,000 on most of them for now. And then on one of these we could say, hey, these 3 single enemies that spawn in here, we could have them moving in a little bit faster. We could set that to 1,300 each. And then just to be different, we could say, hey, this special enemy number 1 that we have here, we could say we want that one to be a lot quicker than all the other ones, so we can set that to be going at 2,000, comma space, and then all the other ones can just be at 1,000. So if they can shoot or not, we will have pretty much all of these just set to false for now. We can have these 3 ships be set to true, and then on our last sequence we could say, hey, we want the first 3 to be false, but then we want the last 2 to be true, they can fire. And those two set to true could be the standard ships that are sort of on like the very edges of our V pattern, and they're just sort of like on the edge firing. Fire rate, just for all of these right now, we can set these to 1.5 like that inside a bracket. The projectile used, yeah, we'll just same thing again, 0, because we'll just have one projectile type for this. And then score give, let's just have it so that all of them give us 100 score, except on the last one we want that enemy to give us a little bit more, so then we would do something like 300, comma, and then 100 for the rest. Now for our locations, this is probably the most in-depth part of this, because you'll need an actual reference to where in the world you are spawning all of these guys. So if we go back into our scene here, if we have it so that where we are spawning our character is on 0, and we want the enemies to be spawning on the same plane as our player, that means that we would have our Z value here pretty much always at 0. I'll just set that to 0.0. And unless we have something very specific that we want to do, like we'll just always keep that Z value at 0. Now something that we could do real quick, we could just throw like a random cube into our scene here. Let's 0 out all its values. And now we have something here where we could say like, hey, from our camera's perspective, when does this cube get off the screen? We could drag it off the screen there. We could say, oh hey, it's around 15,000 on the X value. So then if we want them spawning off of screen and then coming down, we could say, hey, our X value, let's set that to 15,000. And then our Y value here is basically sort of where left and right that we're coming down. So I like to usually like space these apart by maybe 200 units from each other, depending on how big the model is. So we could say on the Y value here, we could say, hey, I want this to be minus 300, which will say that it is the one that is most left out of these three. And to have it in our vector array here to determine the position of each of these enemies and not just one, copy and paste this, making sure that in our vector array that the far left edge and the far right edge have a double bracket, but within that we can go comma paste. So then for our second enemy in there, we could say, hey, our Y value, we can set that to 0.0, meaning that when they come down from the top of the screen, they'll be center aligned. Do that again, comma, paste. And if it gets too crowded here, you can actually just edit the value up here in this section. And then we want that to be a positive 300. So then these will be 3 enemies that come down side by side from the top of the screen. So now that you know the structure of how all of these fields should be filled in, you can fill out the rest of the locations if you want. And then we will get back into the actual game. Cool, so I've set up all of my location arrays here, and just quickly I'll say that this scene column here, it's basically saying, hey, if it's game 0, we could say, hey, this is a scene where we have gameplay happening, and 0 could say, hey, 0 means I want the background grid to be like pink, and then game 1 you could say, actually here is when I would want it to change to blue. It just gives us extra control on what the current scene looks like. But with that done, you would go download or save as, do it over, like make sure that it's a CSV again, and you can just overwrite the current CSV that we have on our hard drive. Save, yes, overwrite. So now if we go back into our data table inside Unreal Engine, we can go re-import and double click here, and now we have all of our data in here. So now that we have our data table stuff kind of sorted out, we're now going to need to go into our game mode blueprint, and we're going to actually use that data from the data table to actually drive our gameplay. So let's create a custom event, and I'm just going to call it spawn loop. And off of event begin play, we can initiate that spawn loop. To have it not happen immediately, we can just have like a 1 second buffer before gameplay actually starts. But then we go spawn loop. Off of spawn loop, get data table row. The selected data table we'll just have as our gameplay data. And for row name, we want to get our spawn loop counter, and to make sure that the input works here, we're going to have to set this to a string and then a string to a name. So it's a little messy, but it does work. Then off of out row, we can break. So then here we can set some of our variables. We can say, actually we can go, hey, this is our current row data set, just to keep track of it like that. We can say sequence duration into spawn delay. We can plug scene into scene. And we'll use our enemy count value here to drive a for loop. So just type in for loop. And for last index, since this is starting at 0, we want to have our enemy count value and just minus it by 1. So then it plays nicely with our for loop. And then off of loop body, we want to spawn an actor from class. So now we need a way to get our array values and just sort of get on a per loop body basis which ones that we actually need for our current spawn actor. So to help with that, we're going to create a custom macro, and I'm going to call it safe get array element. For our input, we would like 2. First one being a wildcard array. Wildcard meaning any kind of array variable type can be put in there. And then a second one, we just want to track our current for loop index, so index integer. And on our output, we want a standard single wildcard just called element. So to create a safe array get, first we'll just drag off of this array and let's get 2 get copies. And on the second one here, we'll plug our index in. And then these can drive into a select, which will be Boolean driven. Put the top one into false and the bottom one into true. And then this can go into element. Basically meaning that if we have an array that, like here, only has a single value, like this, then we want to have that single value applied, like we want all enemies, these 3 enemies, to be type 0. And to drive that in code, we say, hey, if the length of our array is only 1 or lower, always get the first element of that array. The first element in that case would be the only element. Otherwise, we want to get all of the array elements inside that array. So to do that, we'll just drag off here, type in length, and if it is less, and also if it's above or equal, we'll go and then we plug that into our index. So now with that, we can get our safe array elements here, and have the index from our for loop always plugged into index here. And you could say, hey, get our actor, hey, get our locations, etc. And just do this for each of these arrays. So now with that done like that, something I'm just going to do real quickly is with this vector 2D that we've got here, this is the XY multi-data, but in the code that we have here, we have X and Y as separate float values. So to deal with that, we just do a break vector 2D, and then we have different pins for them here. So first one here, actor, we can use that to drive which spawn actor we want to get. So from our enemy classes, we can just say get a copy, put that in there, and then each time it goes through this loop, it can get the correct enemy type to spawn in. Same thing here with our spawn transform. It's just from our location vector that we have here, we can say make transform, and then plug that into here, and then if we need to later, we can just rotate these around to make sure that they're coming down in the right direction towards the player. We'll test that later. But for all these other values here, how do we get these connected into our spawn actor here? Well, to do that, we're going to have to go into our enemy parent blueprint again, and we want to make sure that we have all the values here, all of the variables here that we need to set on on the spawn. We want to have an instance editable and also expose on spawn checked. So once we have all the variables here that we need set to instance editable and expose on spawn, we'll go back to our game mode here, and if we just unconnect these for a second, compile, actually we're going to have to actually just re-put that in, but that's alright. If we just go spawn actor from class, compile that real quickly, let's set this to enemy parent, and then here they all drop down like that, compile and save, connect this back up. So now all of the variables here that we want to have set using the data table into the enemies on spawn, we can just now connect all of these in. So now that we have this core logic here set for having enemies spawn in, we need to be able to say, hey, once we've done that, we want to wait the length of time that spawn delay is, and then go back and do our spawn loop again. So we would first we would increment our spawn loop counter off of completed, and then set that again so that next time we go through our spawn loop, it has moved on to the next row. We want a re-triggerable delay, and we can just put our spawn delay into there. And now, just before I forget, I'm going to come back down here onto where our spawn actor is and have our enemies just spawned, and we want to go add unique, so then we can track enemies that we have just spawned in. And then after our re-triggerable delay, we want to say, hey, actually, let's clear that so that we have a fresh empty array here of the new enemies that we're spawning in on the next spawn loop counter. And then from there we can just say, hey, spawn loop, call that again, and then that'll just keep going through until there aren't any more sequences, which in that case it'll just throw out a row not found. So to make sure that this is working, we can go into our enemy parent. Actually, we can right click, create a child. Let's just call it enemy 1. Go back into our game mode blueprint real quick, into our enemy classes, and we want to make sure that we have enemy 1 here selected, so that we can populate this array variable here with all the different kind of child enemies that we create. But back into enemy parent, we want to be able to just give this a mesh for now. We can actually just borrow the same ship that the player is using on the construction script. So as it's spawning in, we can get our forward velocity value here, which it's nothing here, but from the game mode when we you know, like back in the game mode blueprint graph, we set what this value is on spawn, so it'll have that correct value here. We can go to character movement, and we can just set its max walk speed, and just to be safe, I like setting max crouch speed as well, to this value. Now, to make sure that this doesn't drop like a brick with gravity in our space here, whatever, we need to set some of the character movement stuff here to be the same as the players. So that's certain things like stuff to do with like it falling and stuff, and like having it locked onto a plane, as you can see here. So we want to make sure that these values are set correctly as well. So when we have the character movement stuff set correctly in our enemy parent, go into our event graph, and on tick we want to add movement input to tell our enemy, hey, we actually want to move. And then we just want to get this sort of get forward vector logic here to determine correctly the direction that we have its input going into. So now that we have our add movement here on our event tick, the last thing that we need to do to make our enemy spawn work is to head up into our class defaults in our enemy parent, and we want to go down here to pawn, and we want to make sure that auto possess AI is set to either spawned or placed in world or spawned, because when we have this just set to placed in world only, spawning in this actor the way that we're doing now, where it doesn't just exist in the world on load, we have to spawn it in at a later time. Not doing this will mean that our actor pawn won't move at all. So I'm going to set it to spawned, compile, and save. And now when we hit play in here, coming down from the top of the screen, we will have, maybe coming down a bit too slowly, but we have our enemy ships now. Can do some tweaking to the data table sheet to make sure that we're getting the right behavior that we want, so that they're coming down at the right speed and they're not too, they're not spawned too closely to each other. But yeah, that's pretty much it for this video. We now have enemies spawning in from the top of the screen. So in the next tutorial video that we're going to do for our Space Shooter series, we're going to start work on having the player and the enemy ships fire weapons. So that's where the real fun really begins, I guess. So if you enjoyed this video and you're enjoying the series so far, please make sure that you like and subscribe. You've heard that from every YouTuber now, but still needs to be said. And I hope to see you guys in the next one. Take care, everyone.